Today we're going to learn the simpler type of polynomial where there is no lead coefficient in front of the x squared term. So again, we're doing second order polynomial factoring. You'll see that all of the steps we did last time in section 7.6, not all of those steps are necessary when we do section 4.5. So one thing that makes it simpler is there's never going to be a greatest common factor to factor out. You can't factor out anything if the lead coefficient in front of the x squared term is just 1. So that's kind of a step that we can skip. We're going to start by using the 2 by 2 table method that we learned last class. It's not actually necessary, and you'll see why as we progress through the class. But we're still going to use that AC method. We're going to still find factors of A times C that sum to B. So let's look at our A, B, and C values. A, for everything today, because there's no lead coefficient here, A is always going to be 1. Our B value in this case is 10, and our C value is 16. So A times C, 1 times 16 is 16, and I need my factors to sum up to 10. So I'm going to create my 2 by 2 table where I put 1x squared in the top left corner and 16 in the bottom right. And I need to decide what am I writing with the x and what am I writing with the x. Well, factors of 16. Factors of 16 would be like 1 and 16, or 2 and 8, or 4 and 4. And once, if you're systematic, remember, if you're systematic about making this factor table, once you once you hit the same number or close to the same number in your factors, you know that you've run out of factors at that point. So 2 plus 8 equals 10. So that's the factor pair that I'm looking for here. So I'm going to write a 2 in the bottom left corner and 8 in the top right corner. Now, how do I work backwards and find my column and row headings to find the factors? If I write 1x up top and 1x on the side, 1x times 1x is always going to equal 1x squared. So how do I know what number to write at the top of this column? Well, it's 8, because 8 times 1x gives me 8x. How do I find my missing row heading? It must be the number 2, because 2 times 1x gives me 2x. And then my bottom right corner should just work out for itself, and it does. 2 times 8 is 16. So look at my my multiplication problem. My factored form is x plus 8 times x plus 2. Remember, we don't write the 1 coefficient in our final answer. So this is the correct form. Remember, if your factor here is not negative, it's positive, and that's why we've written these as addition problems inside each parenthesis. So the same tips that we learned last class apply today. If AC is positive and B is positive, both factors must be positive. If AC is positive and B is negative, both factors must be negative, etc. So let's look at this example here of x squared minus 8x plus 12. Here, when we again, there's no greatest common factor to think about. We're just focusing on what A is, what B is, and what C is. And A times C is 1 times 12, which is 12. And I want those factors to add up to B, which is negative 8. What are my various factors of 12? Well, they could be 1 times 12, or they could be 2 times 6 or 3 times 4. And my factors are close to each other, so I've exhausted on my factors. Now, remember, because AC was positive and B is negative, both factors must be negative. So I want to have negative, 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 everything's negative. So which of these factor pairs adds up to negative 8? Well, this adds up to negative 13. This one adds up to negative 8. This is the one I want to use. This would have added up to negative 7. So let me create my data table with my 1x squared in the top left and my 12 in the bottom right. I have negative 2x in this corner and negative 6x in this corner. And I'm ready to factor. In order to get 1x squared, I must have a 1x on the top and a 1x on the side. So notice the pattern we've kind of come up with so far, right? 1x on the top, 1x on the side. We're kind of always starting with 1x and 1x. And then 1x times what gives me negative 2x? This must be negative 2, and this must be negative 6. And if I've factored correctly, my bottom right corner should work out for itself, and it does. Negative 2 times negative 6 is positive 12. So look at my answer again. X minus 2 times x minus 6. Look at this answer and compare it to the previous answer. Do you see why we don't actually need to use the data table to work backwards? Do you see how the factors that we discover just get used in the multiplication problem? Matches the negative 2 and the negative 6. There's nothing wrong with doing the 2 by 2 table. The 2 by 2 table always works. However, while this is kind of a necessary part of the method, as when we're doing polynomials with a lead coefficient, it isn't actually necessary when we're doing polynomials without the lead coefficient. So we're going to do this one more time using that the 2 by 2 method just to practice it, because sometimes you get polynomials with a lead coefficient, and I need you to remember how to do that. But this method kind of shows you it's not totally necessary. So we'll do one more with the 2 by 2 method, just to prove to you that it does always work. So my A value is 1, my B value is 4, my C value is negative 21. So A times C, 1 times negative 21 is negative 21, and my B value is positive 4. The factors of A times C, that sum to B. My factors of A times C. Now notice this time A times C is negative, so it's going to be one of these two procedures here. But my B value is positive, so that's this situation. That tells me that my large factor is going to be positive and my small factor is going to be negative. So when I make my factor list, 1 times 21 or 3 times 7, and those are actually all the factors of 21, my large number has to be positive. My small value is going to be negative. So negative 1 plus 21 is 20. Negative 3 plus 7 is positive 4. This is the factor pair I need. Let's make our 2 by 2 table. And I've got 1x squared in the top left, negative 21 in the bottom right, and I need my negative 3x and my positive 7x as the remaining two boxes. As before, we have to have a 1x on top and a 1x on the side as my first row and column headings to get that 1x squared. And then I need to have a 7 up top because 7 times 1x is 7x. And I need to have a negative 3 on the side because 1x times negative 3 is negative 3x. And the bottom right-hand corner does work out. 7 times negative 3 is negative 21. So what we find one more time is that x plus 7, that's a positive 7 because it wasn't negative, times x minus 3 gives us the correct factored form of this polynomial. And again, we could have gotten there right away just by using the negative 3 with x and the 7 with x. So for our remaining problem, we will go ahead and take the shortcut. We aren't going to use the box this time because hopefully the patterns that I've shown you have demonstrated that it's not necessary. So a farmer plants a rectangular strawberry patch in a corner of a square plot of land as shown. The area of the strawberry patch is 600 square meters. What is the area of the square plot of land? Okay, so we've got this rectangle here on the side. And the length of this strawberry patch here is S minus 40, because this was a square field, and the remaining kind of patch that isn't strawberry patch is S minus 40. And then over here on this side, we have S minus 30. So my strawberry patch area is length times width, but my area is 600 square meters, and the length was S minus 30, and the width was S minus 40. Here I can use FOIL to multiply these together. S times S is S squared. S times negative 40 is negative 40S. Negative 30 times S is negative 30S. And negative 30 times negative 40 is positive 1200. But all of that equals 600. I have some like terms that can be combined here. So I've got S squared minus 70S plus 1200 on the right side, and that still equals 600. But if I want to solve for my missing variable, if I want to solve for S, what I need to do is write this math problem as a multiplication problem that's equal to 0. So first of all, I need to get 0 on one side of the equation. I need to have all of my variables and all of my constants on one side and 0 on the other. So I'm going to subtract 600 from both sides. And I have 0 equals S squared minus 70S plus 600. Now I'm ready to factor this and write it as a multiplication problem. So how do I do that? Let's see, there's no lead coefficient. I want to think of factors of AC that sum to B. Well, what is AC? A is 1, B is negative 70, and C is 600. So 1 times 600 is 600. I need factors of the number 600 that add up to negative 70. This is one of those problems where both factors are going to be negative, because a negative times a negative is a positive, and the number I'm trying to multiply to is positive. But when I add the factors together, it equals a negative number. So my possible values for S are, let's see, I could do 1 times 600. I could do 2 times 300. I could do 3 times 100. So 4 times 150 is 600. 5 times 120. 6 times 100. No 7, but 8 times 75 works. Scroll down a bit. 10 times 60 works. 12 times 50. 15 times 40. 20 times 30. And 24 times 25. So if all of these kind of factors, and remember, these do both have to be negative. So these are all negative all down the way. Out of all of these factor pairs, the pair that sums to negative 70 is negative 10 and negative 60. That adds up to negative 70. And so that is the factor pair that we're going to focus on. So as I factor this, we're going to write s minus 10 times s minus 60, and that is the factored version of this polynomial. And but we haven't answered the question yet. This question did not ask us to just factor this polynomial. It asked us first to solve for s. And remember, as we've learned in previous units, that we solve for s by realizing that this is a multiplication problem that equals 0. So if the multiplication problem equals 0, one of the terms must equal 0. Either s minus 10 equals 0 or s minus 60 equals 0. And so solving for s, here I can add 10 to both sides of the equation, and I get s equals 10. Looking at the other equation, I can add 60 to both sides of the equation, add 60 to both sides, and I get s equals 60. So, does this question have two answers? This question does not have two answers. If we look at the original problem, it doesn't make sense for this to be a 10 by 10 square, because then I couldn't have all of this space on my patch, 40 meters worth of length on one side of my square and 30 meters worth of length on the other side of my square. So 10 doesn't make sense as a side length. So the only answer that makes sense in the context of this problem is a 60-meter length square. If I had original 60 meters by 60 meters, then the original area of the square plot of land, 60 times 60 is 3,600 square meters of land. I hope this helped.